it going, everybody? Hope you're doing well. It's Mr. Bonhomme. Really quickly, I want to show you about polygons. We are currently covering a unit that has to do with geometry, shapes, angles, different type of lines, different type of attributes that we can describe shapes, so we can understand some of the things that are similar, some of the things that are different. All right. So a polygon. Some of the terminology is really important. The vocabulary is really important. So try to use this language at home as well. Polygons are shapes that have straight lines. For example, a circle, not a polygon. No straight sides included. So we call this a non-polygon. And also, if you see something like this, a heart, non-polygon. Also, if you see something like this that has straight sides, okay, let's say that those are straight, but it is enclosed and connected all together, non-polygon. So now, since we have that out the way, polygons might look like this: 5 sides, a pentagon. But specifically, we're going to get into quadrilaterals. Quad is a prefix, means 4. So this is what we've been really focusing on for 3rd grade. So examples of quadrilaterals, a lot of students can name some. One that is known by 3rd grade is a square. Another one is a rectangle. This one, a lot of students may become confused with and say, hey, that's a diamond or a kite. It's not really math terms, so we try to get away from that. But when thinking about it in the real world, yeah, those items, those objects could be what this is, which is a rhombus. I'm going to write it out also. This is a trapezoid, and this last one, a parallelogram. Okay, so this is a square, this is a rectangle, this is a rhombus, this is a trapezoid, and this is a Okay. Now I'm going to tell you what are some specific attributes, different ways that we can describe these quadrilaterals. What makes them similar, what makes them different, so students can see the connection. Down here, I have some attributes for polygons. They might have parallel lines. That means that sides that are opposite of each other, if they continue, they will never touch each other. Something like train tracks. Acute angles, very small, very tiny. You can make them doing the letter V. Right angles, you can make the letter L, and it's 90 degrees. And then obtuse are very wide, right? So we've been practicing this in the classroom, very wide. Now, for a square, I'm going to use some of these to kind of help us see some of the attributes. A square has one pair of parallel lines, right? A pair is 2, the opposites, and then it has another pair. So this would be the first pair of parallel sides. This would be the second pair. Okay. All of these actually have 2 pairs of parallel sides, except for a trapezoid. So for a rectangle, these are parallel, and then the top sides are usually longer, or it could be the sides, doesn't matter. And that's your second pair of parallel lines. A rhombus, these sides are parallel, and these sides are parallel. So it has 2 pairs of parallel lines. And like I said, for a trapezoid, these sides, if they continue, right? Let's say I continue them, whatever. They continue to be parallel. However, on the sides, they kind of slant down. Those are not parallel because eventually, if they keep on going, they're going to cross each other and they're going to make like a triangle. All right, so a trapezoid is the only quadrilateral that has one pair of parallel lines. So that's what makes it a little bit different than all the other quadrilaterals. These are not parallel lines, not parallel. So it only has one pair. Then a parallelogram is called a parallelogram because it can look stretched out like a stretched out rectangle. It could be a rhombus. It could be a square. It could be a rectangle. A square, rectangle, rhombus all fit into a parallelogram because it just needs two pairs of parallel lines. Two pairs of parallel sides. Okay, so it could be a square, rectangle, or rhombus. Okay. Now something that is specific for a square, and I'm going to redraw it again, is that because for this example I was just talking about the lines, right? Now I'm going to talk about the attributes in terms of the angles. And we have the right angle. So for a square, as you can see, right angle, right angle, right angle, right angle. Boom. And I'll connect those together. And you know a right angle because it looks like the letter L. And then you can also put a square inside that space. So that's how you know if it's a right angle. You put a square right there so then you can see. So I'm going to connect that. Boom, boom, boom. And that's a square. A rectangle also has right angles. 4 right angles. 1, 2, 3, 4. Then I could connect it. Alright, that's a rectangle. It has 4 right angles. The only difference between a square and a rectangle is that all the sides are equal in the square, and the rectangle, only 2 of the sides are equal. Like the opposite sides are equal, but not all 4 sides are equal. Then you have a rhombus where all the sides are equal. And sometimes it could have a right angle, sometimes it doesn't. That's really it with a rhombus. All sides are equal with a rhombus. Anything with all sides equal, it could be a rhombus. So a square can actually be a rhombus if it looks like this, or if you kind of rotate it. All right. And then for a trapezoid, the type of angles are obtuse angles. They're kind of wide. And then you have acute angles that are like a little bit skinnier. And this is not perfect, so this is a good example because it isn't perfect. But you get the gist. And then parallelograms, like I said, they could be a square, rectangle, or a rhombus because of 2 parallel lines. So the angles really don't matter for a parallelogram. So this was just really quick. Hopefully you got something out of it. But categorizing and seeing some attributes of different quadrilaterals, really helpful. Looking at the type of lines, specifically the parallel lines. And then the angles, acute, right, and obtuse. And also seeing if all angles are the same length, like in a square, like in a rhombus. So those are some things that can help you out at home, especially maybe seeing some quadrilaterals around the home and being able to identify them. Hopefully this was helpful and you're able to just see in the real world some of these quadrilaterals and some of the attributes of polygons just in general. Okay? This is Miss Bono. Peace.